visi Guru AYU, mencapai misi yang satu, permisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hai, selamat petang semua. Okey, sebelum tu saya nak belanja satu rangkap pantun dahulu. Bersinar cahaya di senja 6 petang, berlari-larian si anak dara. Pemanis kalam, selamat datang. Awal bismillah, pembuka bicara. Bismillahirrahmanirrahim. Assalamualaikum dan salam sejahtera semua. Saya Cikgu Rosmeliani binti Zaini, bertugas di SMK Bandar Bintulu, Sarawak dari Akademi YouTuber bersiaran dari channel Cikgu P. Okey, sebelum kita mulakan kelas kita pada petang ini, lebih molek kiranya kita mulakan majlis ilmu kita dengan bacaan Ummul Kitab Al-Fatihah. Bismillahirrahmanirrahim. Amin amin ya rabbal alamin. Alhamdulillah bersiaran kita sekali lagi dalam kelas tuition online akademi YouTuber yang juga merupakan kerjasama e-didik Malaysia dan Kelab Guru Malaysia. Sebelum kita mulakan kelas kita, ingin saya ingatkan kepada semua pelajar dan penonton yang ingin menghantar komen, sila gunakan bahasa yang sopan dan gambar profil yang bersesuaian dengan tontonan umum. Sila fokus pada isi pembelajaran yang akan disampaikan oleh Cikgu P. InsyaAllah semoga kelas kita dapat dimanfaatkan sepenuhnya oleh para pelajar. Ambil peluang ini, ikuti setiap kelas online percuma panitia fizik menengah atas yang akan bersiaran pada setiap minggu pada hari Ahad pada jam 2 petang. Baiklah, saya akan perkenalkan guru-guru yang bersama kita pada petang ini. Saya sendiri akan bertindak sebagai control host dan moderator pada petang ini. Dan kita ada presenter kita Cikgu Peh Kok Hua yang kini bertugas di SMK Bandar Jaya, Batawa, Pulau Pinang. Okey, nanti beliau akan perkenalkan diri lebih detail lagi ya. Okey, juga diingatkan link sijil penyertaan akan diberikan di penghujung kelas ini. Sila ambil perhatian. Link tersebut akan tamat dalam tempoh setengah jam selepas live. Hanya email e-didik, Jawi dan MOE sahaja yang diterima. Tanpa melengahkan masa, mari kita ikuti kelas fizik pada hari ini yang akan disampaikan oleh Cikgu P. Dengan segala hormatnya, dipersilakan. Okey, Cikgu P.
Hai, selamat petang kepada semua. Okey, so saya Mr. P. Okey, so kini mengajar di College Tingkatan 6 Tun Fatimah, Melaka. So, selaku presenter pada hari ini. Okey, so ini merupakan tuition percuma daripada panitia fizik AYU. Okey, so kita ada 2 kelas. Okey, untuk kelas tingkatan 4 diadakan pada setiap Jumaat malam 9.30 dan mereka grup tingkatan 4 sekarang kita sudah sampai tajuk 4.3 haba pendam tentu. Okay, so disampaikan oleh Cikgu Faizal. So siapa yang belum lagi menyertai, okay, ada hadir kepada kelas tersebut, bolehlah pergi channel Cikgu Faizal, okay, untuk subtajuk tersebut. So untuk yang kelas tingkatan 5 seperti hari ini diadakan pada setiap hari Ahad pukul 2. So kita sudah sampai tajuk 5.1. So ini merupakan panitia fizik SPM Akademi YouTuber Malaysia. So hari ini bersama saya petang ini ada Cikgu Yani. So terima kasih Cikgu Yani bersama saya pada petang ini. Okay, so we have already reached the new chapter. So we are now at chapter 5, okay, electronic. And today we are going to our first subtopic of chapter 5. That is the 5.1 Electron. And for today's lesson, we have total 3 learning standard you need to understand. So for the first learning standard, so you have to able to describe the thermionic emission and the cathode ray. So what is the thermionic emission? So the thermionic emission is the emitting of the electron from the metal surface when heat energy is supplied. So you can look at the figure here. So the heat is actually come from the power supply, okay? And the surface of the filament, okay, will be heated and the electron will be released from the surface. Okay, so for the first, you can look at the figure, this figure, okay, metal piece. So the metal has 3 electrons that move in lattice structure, but does not have sufficient energy to escape from the metal surface because of the strong nuclear attraction. So you can look at the figure 1 here. So the lattice structure referring to the structure of solid here, okay? And there is a lot of the electron, okay, move around. Okay, and if let's say we take out one of the atom from the metal piece, okay, will be look at this figure will be almost like this figure. So the electron is moved around the nucleus, okay, and attracted by the nucleus, okay, which is consists of the proton and neutron. Okay, so that means that with not sufficient of energy, the electron is not able to flow out. Okay, and then for the figure number 2, okay, so you can see that when the metal is heated, the electron will acquire enough energy to escape from the metal surface. So that means that when we give the heat for the metal, so the electron will be able to overcome the attraction from the nucleus and release from the metal surface. Okay, so the occurrences of emitting the electron from the metal surface when the heat energy is provided, so we know as the thermionic emission. Okay, so the factor that affect the rate of the thermionic emission, so that means here, how we can increase or decrease the emission of the electron from the surface of the metal. So here we have 4 factors. First, temperature of the cathode. So when the temperature increases, the rate of the thermionic emission increases. So that means we increase the temperature for the metal surface, okay, which supplied by the power supply here, okay. So that means that when the temperature of the metal surface increase, so the more electron will be released from the metal surface. Okay, then the second will be the surface area of the cathode. Okay, so this is a cathode. So when the surface area increases, the rate of the thermionic emission will be increases. So for sure that the surface area increases, so the chances of the electron release will be more. And then the third factor affecting the rate of the thermionic emission will be the type of the metal. So different type of metal has different rate thermionic emission. So the good metal like tungsten, barium oxide, and sodium oxide has high rate of the thermionic emission. Okay, so here another one will be the specific heat capacity of the cathode. So the smaller the specific heat capacity of cathode, the larger the rate of the emission. So as we learned already, the terms of the specific heat capacity will be the indication of how fast the temperature can be increased by the substance. So that means that if the substance have the smaller specific heat capacity, so that it will be more easy to increase its temperature when the same amount of energy is provided. So that means this is also related to the temperature of cathode ray. Okay, so here there will be 4 factors. The first, temperature of cathode. Second, surface of surface area of cathode, type of metal, and the last one will be the specific heat capacity of the cathode will be affecting the rate of the thermionic emission. Okay, then after that, the definition for the cathode ray. Just now we have already know what is the definition for the thermionic emission. For the learning standard 1, there is another terms you need to understand. The definition will be the cathode ray. Okay, so the cathode ray is a narrow beam of the fast electrons moving in a vacuum. So you can look at the figure here. Okay, so the electron beam will be referring to the red arrow here. Okay, so there is a fine beam of electron emerges from the hole. So the hole here is referring to the anode. Okay, later on we will discuss detail for the structure for the cathode ray oscilloscope here. Okay. Okay, so after electron has been released from the heated metal surface, a narrow beam of the fast moving electron is produced. So just now we mentioned that the cathode location will be here. So when the power supply is supply the heat, okay, for the cathode, so that means the filament here will be heated, okay, then the heat will be transferred to the cathode. And the thermionic emission, which is the emission of the electron on the metal surface, will be occur. So here you can see, here will be the electron emitted in the many direction. So that means this position here will be the electron emitted from the surface of the cathode. Okay, and then with the high voltage supply will be accelerate to this part, which is known as the anode cylinder. Okay, and then the red arrow here represent the beam electron moving to strike the surface of the fluorescent screen here. Okay, so that means here there is the narrow beam fast moving electron. Okay, at the right arrow here. Okay, so the second, cathode ray can be produced by using an electron gun. So the electron gun will be this lah. Okay, and the electron gun is also known as a cathode ray tube. So this is also known as the cathode ray tube lah. Besides, we know as the electron gun. Okay, so you can look at this GIF. Okay, so this is the appearance for the cathode ray tube here. Okay, so now we go to the detail for the design of cathode ray tube, or known as the electron gun, just like I mentioned already, and how it works. So basically, you can see here is the position of the cathode where the thermionic emission will be occur at this part. Okay. Okay, so the cathode is heated by the tungsten filament. So you can look at here, the tungsten filament is connected to the AC supply. Okay, and then the second, here you have to understand the parts of the high voltage supply, where is also known as the extra high tension with the symbol short form EHT. And then the second will be the position of the anode cylinder. Okay, so the anode here will have a small hole inside here, so which allow the electron to flow through. Okay. Okay, so look at the sentences number 2. The heated cathode emits electron and is accelerated at a high speed between the anode and cathode. So the cathode will be here, the anode will be here. Okay. Because a high voltage is applied between the cathode and anode. So the high voltage here, where is also known as a EHT, okay, able to accelerate the electron emitted from the cathode. So as we know that the electron is with the negatively charged, so the anode is positive, so we attracted the electron towards itself, okay? So that means the electron will be flow or attracted from the cathode to position of anode. So that means it will be moved forward lah. Okay, so the electron now will be accelerate between the cathode and anode lah. Okay, so the third, here we have the vacuum. So the vacuum glass tube is used to prevent the collision of the electron with air molecule. So that means in the cathode ray tube, okay, is in the vacuum condition. There will be no any air molecule inside the tube. So to prevent the electron collide to the air molecule. Okay, so that means the electron here will be moving smoothly lah, without any blockage by the air molecule. So the fourth will be the foreign set screen. Okay, so it will be here. So the accelerated fine beam electron strike the foreign set screen and causes the foreign set screen to become green color. So that means when the electron hitting the surface of the foreign set screen, okay, so the green color light will be appear at the surface lah. Okay, so the 5 here, as mentioned, here will be the fine electron beam. Okay, so the electron beam will be also known as the cathode ray. Okay, so the electron released from the surface of cathode will be accelerated by the anode to the foreign set screen. Okay, so this electron beam is known as the cathode ray. Okay, so the next will be the type of the motion of cathode ray in the cathode ray tube. Okay, so here, as mentioned just now, the electron emitted from the metal surface, okay, in the process of thermionic emission. Okay, so the P will be the cathode, the Q will be the anode. Okay, so the EHT, okay, will be help to accelerate the electron from the metal surface, okay, to the position of anode. Okay, and then from the anode here, at position Q will be moved forward to the screen here at the position R. Okay, so you can look at the table here, the PQ referring to the motion of the electron from cathode to anode. P will be cathode, Q will be anode. And then the next will be the anode, Q to the screen. So the anode will be Q and the screen will be out. So what is the motion between these two regions? Okay, so cathode rays are produced by creating a high potential difference between the cathode and anode by using EHT, so which is the extra high tension. Okay, so that means at this position, due to the high potential difference, so the electron beam will be accelerated. Okay, and then the negatively charged electron are drawn towards the positively charged anode with high velocity. So that means the electron beam will be moving at high velocity. Okay, so here, the type of motion at region PQ will be uniform acceleration. Okay, so that means the electron will be accelerate at region P to Q. Okay, while for the Q to R, the electron will be moved in uniform velocity. Okay, so this is a different motion between these two regions. Okay, PQ, where is the cathode to anode, and the anode to screen. Okay. Okay, so we have already discussed the detail in the learning standard 1. So now we go to the question number 1. Okay, so for the first, this is the question in 2012. Okay, so what particles escape from the surface of the metal when it is heated at a high temperature? Okay, so student, you can share your answer, okay, at the chat room. Okay, okay, so Jia-Ying, okay, good afternoon. So kita ada Cikgu Hasita juga, okay, so selamat petang, Cikgu Hasita. Okay, so what is the particles will be escaped from the surface of metal here? Okay, so as per mentioned just now, so you can see there is a electron will be emitted, okay, at the metal surface when the heat energy is supplied by the AC power supply here. Okay, so when metal is heated to a high temperature, electron will be escaped from the surface through the process of thermionic emission. Okay, so this will be very clear that the answer here will be D. Okay. Okay, then the next question number 2. Okay, so this is also one of the past year question in 2014. So diagram shows a vacuum. Okay, shows a vacuum tube used to investigate the thermionic emission. Okay, so what is the function of the cathode? So you can look at here, the cathode will be here. Okay, so again, this is a process we know as the thermionic emission. Okay, so when a metal is heated to a high temperature, electron escape from its surface through the thermionic emission. So that means these 2 years will be tested for the same thing lah, okay, which is related to the thermionic emission. Okay, so the function for the cathode here will be providing the electron, right? Okay. Okay, so here A to produce the electron when it is heated by filament. So the answer here supposed to be A, right? Okay. And the B to accelerate the electron at a high speed. So this will be the function for anode. And then the C to control the intensity of the electron beam. So that means we need to control the rate of the thermionic emission. Okay, so we have to control. Yes, okay. So here, okay, so we have the students here, Kulan High, right? Okay, Kulan High. Okay, so your answer A, so should be correct. Okay, thank you for your sharing your answer in the chat room here. Okay, so I also think that the answer will be A. So we look at others option. So the C will be controlled by the EHT, right? So if the potential difference is high, so for sure that there will be a higher speed or more electron will be speeding to position of anode. Okay, and we also can control the temperature at the cathode here. Okay, to releasing the amount of electron here, but this is related to the power supply energy lah. Okay, and then the D to deflect the electron beam vertically. Okay, so here will be diffraction plate. Okay, so the diffraction plate later on at the learning standard 2 will be more clear. Okay, so you are right. Okay, so the Kulan High here, okay, answer here will be A. Okay, so the question number 3 is the past question in 2013 here. Okay, so which particles is cathode ray? Okay, so what is the cathode ray? So A here, electron beam. B will be gamma ray. C, neutron. D, alpha particles. Okay, so as mentioned just now, okay, in our structure of the electron gun here. Okay, so here mentioned that at this position, there is a fine beam of electron emerges to the front here. So the answer here is very clear that it will be A, electron lah. Okay. Okay, so this is the answer A. So the question number 4. Okay, so this is also one of the past question. Okay, so students, you may share also your answer in the chat room lah. Okay, so diagram shows the process of electron escaping from the surface of the heated metal. So what is the process? So A, radiation, B, evaporation, C, rectification, D, thermionic emission. Okay, yes, okay, Guggenheim. So answer here, very clear that they will be referring to thermionic emission, okay, which is a process of emitting electron, okay, on the surface of metal when it is heated by the power supply. Okay, so the answer here will be D. So very good. Okay, so we have already finished our learning standard 1. So we go to our learning standard 2 for today's subtopic 5.1 Electron. Okay, so the learning standard 2 here will be describe effects of electric and magnetic field on cathode ray. Okay, so we need to study this effect lah. Okay, so here we have to understand the characteristic of the cathode ray. So first, the cathode ray move linearly in the vacuum, so it will be like the light, okay, travel in straight line, okay. So the second, as we know that the cathode ray is a beam of the electron emitted from the metal surface, so they will be negatively charged. Then the third, it will be deflected by electric field and the magnetic field. So the figure here referring to the effect or diffraction by electric field. Okay, so you can see there is a two plate here. Okay, deflection plate. Just now I mentioned already. Okay, so this will be the diffraction by electric field. And here you can see there is a magnet here. Okay, so the magnetic field will be also deflect the cathode ray here. Okay, later on we'll discuss more detail. Okay. Okay, then the next will be have a high velocity, kinetic energy or momentum. Okay, so as per mentioned just now, due to there is a extra high tension where there is a high voltage or potential difference between the cathode and anode, so the electron beam will be moving at the high velocity, okay, because it is they will be accelerated by anode, okay. And then it will be cause the foreign set screen luminous. So that means you can see a green light appear at the screen in front. Okay, so basically here will be the 5 characteristic of the cathode ray. Okay, so now we have to prove the characteristic we mentioned just now, okay, in the experiment. Okay, so here we have to investigate the characteristic of the cathode ray. So the characteristic of the cathode ray are investigated by using multi-cross tube and depletion tube. Okay, so here we have two apparatus to show or to prove the characteristic of the cathode ray. Okay, so here the first we have the multi-cross tube. Okay, so you can see there is a cross in the electron gun here. Okay, so this apparatus we will know as the multi-cross tube. So we will use that to see the characteristic of cathode ray where they move linearly in the vacuum. And then deflected by the electric field and magnetic field. So here actually is deflected by magnetic field. Okay, but actually we still able to see the deflection of the electric field by using the deflection tube. Okay, and with this multi-cross tube, it also able to show that the cathode ray will cause foreign set screen luminous where appear the green color light, okay, at the front, okay, of the screen. Okay, so the diffraction tube will be like this Okay, you can look at the middle part. Okay, at the tube, there is the metal plate here. Okay, so when the metal plate connected to the positive, so this plate position will be positive lah. Okay, positive plate. And the bottom part, if you look at this, this position will be connected to the negative of the power supply here. So that means the plate at the bottom will be a negative plate. Okay, you can use to show the deflection of electric field. Just now I mentioned already. So for the multi-cross tube, able to show the deflection of the cathode ray by the magnetic field, while the deflection tube able to show the deflection of the cathode ray by electric field. Okay, and this deflection tube also able to show that the cathode ray is negatively charged. Okay. Okay, so you can look at the first. Okay, we want to investigate. Okay, the cathode ray is travel in a straight line. Okay, which is also showing the same character as the light. Okay, so the first, the 6-volt heater is switched on. Okay, it will be switched on. So that means the heating filament will be heated. Okay, so the electron will be emitted at the surface of the cathode. Okay, so a shadow of the cross is seen. So you can see a shadow here. Okay, because the multi-cross at the middle here will be the opaque object. So it will be block the emission, okay, the thermionic emission, okay, or the light appear at the cathode here. Okay, will be look like this lah. Okay, so you'll see a yellow color light, and there is a shadow close at the screen in front. So will be like this lah. Okay, so the shadow is formed by the light ray from the heated filament. So that means there is a light at here. Okay, due to the thermionic emission is occur here. Okay, but the electron will be not moving forward lah. Okay, because the EHT here is still off lah. Okay, so the conclusion. Okay, so here you can see the heating filament will be heated. Okay. Okay, so the conclusion here will be the light ray travel in a straight line. So we prove that the cathode ray will be like a light travel in straight line and able to block by opaque object. Okay, so the second, cathode ray cause fluorescent screen luminous. Okay, so again, we're using the same apparatus, multi-cross tube, to prove the characteristic of the cathode ray, where we'll be showing the fluorescent screen effect. Okay. Okay, so here you can see the procedure. Now the 3 kilovolt power supply is connected between cathode and anode. So that means here the EHT supply is on. Okay, so that means the anode will be attract the electron to front. Okay. And then will be strike the fluorescent screen. Okay. Okay, so a green shadow of the cross is seen. It is the same size and at the same position as the shadow formed by the light earlier. So that means they will have the same position of the cross. Just the color just now is the yellow, now already changed to green color. Okay, so the shadow of the multi-cross is still will be there. Okay, you can see the shadow of the multi-cross will be still appear. Okay, due to the light or cathode ray will be blocked by the opaque object. Here will be the multi-cross lah. Okay, but the screen will be appear growing green color. Okay, just now will be the yellow color. Okay, will be like this lah. Okay, so the explanation, the shadow is formed by the cathode ray. Okay, because now the cathode ray is strike the fluorescent screen. Okay, so the conclusion here, the cathode ray travel in a straight line because the formation of the shadow here. Oh, and then the second, the cathode ray cause fluorescent screen. So fluorescent screen, that means there is a green color luminous appear at the screen here lah. Okay, so the cathode ray carry kinetic energy, which is converted to light energy when they hits the screen. Okay, so the kinetic energy, okay, already changed to the light energy here lah. Okay, then for the third, okay, is study for the cathode ray deflected by the magnetic field. So again, so as per mentioned just now, the multi-clause tube will be used to show the deflection of the cathode ray, okay, by the magnetic field. Okay, so here, the north pole of the bar magnet is brought close to the cathode ray. So you can see, okay, so we use the magnet and we point the north pole towards the cathode ray. Okay, so what you can see, okay, so you can see that the cathode ray shadow is moved and deflected down. Just now, we have the shadow at the middle here. Okay, but you can see here, when we use the north pole of the bar magnet towards the electron beam here, so the shadow move to down. Okay, so that means the beam moving to down lah. Right? Okay, so the shadow position is changed already lah. Okay, so the deflection showing that will be go to the down. Okay, so why? So this is because a catapult force is produced because of the cathode ray carry a negative charge. As we know that the electron flow will cause the current flow, but they will be at the opposite position. Okay. So it acts as the perpendicular to both current and the magnetic field. So the current is produced by the electron beam, okay, and the magnetic field is due to the magnet here. Okay, so because of these two field, current and the magnetic field, cause the catapult force to produce. Okay. So here, the conclusion, the cathode ray can be deflected by a magnetic field. So we see the observation just now where the shadow moved downward already. Okay, so that is deflected by magnetic field. So the location or position where the beam will be moved, able to determine by using the Fleming left-hand rule. Okay, so the Fleming left-hand rule we already learned at our last chapter, right? Okay. Okay, so will be our thumb showing there is a motion. Okay, here is the catapult force lah. And then the B here will be our first finger showing the direction of the magnetic field. Okay, so the magnetic field here, as we know that the north, okay, the bar magnet will be like this, right? So we know that the magnetic line will be come out from the north and then to the south position. Okay, so that means it will be like this lah. So the north showing that the magnetic field direction will be out from the north and then to south. Okay, and our second finger here will be the direction of the current. So here the current will be the opposite direction of the beam. Okay, as per mentioned just now, the beam will be moving front. Here will be at the right position. So that means the current will be at the left lah. Okay, current will be at the left. Okay. Okay, so here, note, okay, so the direction of the cathode ray is opposite to the electric current. Okay, so here will be the opposite direction here lah. Okay, so we're using our left hand. Okay, so you can see that here, the current will be at the opposite position of the cathode ray. Okay, so just now I mentioned already, CR here is cathode ray will be moved to the right. Okay, and in this figure, so that means the current will be at the left lah. So your second finger have to point to the left, to your left, okay, to your left. And then the next, you can see, just now I mentioned already, the direction of the magnetic field will be from the north. So that means will be, I put here in, that means in your screen lah. Okay, so that means your second finger to the right. Okay, and then your magnetic field, your first finger will be in. Okay, so will be like this lah, your hand. Okay, so your first finger north in your screen, then your second finger is opposite direction to the cathode ray, so will be at your left. So you can see your thumb, which is showing the position of the force. The cathode puts force here will be to the down here. So that's why you can see, okay, the shadow is at the down. Okay, because the beam is moving downward. Okay, cause the shadow of the multi-clause to the down here. So that means we can using the Fleming's left-hand rule to determine the position, okay, the position of the cathode ray. Okay, okay, so here will be bottom lah. Okay, okay, so here you can look at the GIF here. So you can see when the magnet is brought closer to the beam, so the beam is moving upward. Okay, so what is the pull of the magnet towards the beam here? Okay, so again, using the Fleming left-hand rule. Okay, so it will be like this. Okay, so here you can see my thumb at the figure here showing upward, because you can see the beam is moving up when the magnet is brought to the electron beam here, or cathode ray lah. Okay, so that means the force will be up, and then the beam is moving in front. So that means the current will be at the left also lah. So again here, our thumb will be moving up, and our second finger will be to the left. Okay, so to the left. So that means that will be almost like this lah. So your first finger, which is showing the position of the magnetic field, will be out of the screen here, right? So when out to the screen, so that means will be sub. Okay, so you can get position of thumb showing the beam is moving up, and then the second finger here move to the left, and then your first finger, which is the magnetic field, will be up from your screen. Okay, so will be south lah. So we can know that there will be a south. Here will be the south. Okay. Okay, then the next will be the cathode ray deflected by electric field. So for this, we're using the diffraction tube already changed. Okay, we changed the middle part to the metal plate. Okay, so here the first, okay, so 6-volt heater supply and the 3 kilovolt power supply are connected. So here is connected, okay, but the metal plate is not connected. Here is not connected. So you can see here we have three power supply here. First, here heater supply is connected. Second, okay, here the EHT, okay, is connected. So that means the beam is moving in front. Okay, but the third power supply here is off. So that means there is no any electric current flowing to the plate. So you can see the observation. Okay, so this will be the straight line. Okay, at the screen here. Okay, so explanation here, no electric field between the two metal plate. Okay, so that means the cathode ray travel in a straight line here. Okay, again, this is another proof lah. The cathode ray will be travel in straight line. Okay, and then the second, also the diffraction of the electric field. Okay, but now, what's the difference here? You can look at the procedure. So 6-volt heater supply and 3 kilovolt power supply is connected. So that means these two is connected. And the 1000-volt supply is also connected. So that means 3 of these is connected. Okay, so you have to see the observation here. Okay, you can see the cathode ray is already moved up. Okay, so why? Okay, so you can see the first explanation here is the cathode ray is deflected upward or plate positive here. So you can look at the here is the long of the electron. This is a battery, right? Okay, so the long indicate there is a positive position. Okay, and then the bottom with the short hearts, okay, for the symbol here, they will be negative lah. So here, very clear that the bin electron is negatively charged. Okay, is negatively charged lah, so will be moved towards the positive plate. Okay, so the conclusion here, cathode ray is negative charged. Okay, and then the next. Okay, so here it will be the cathode ray diffraction by the electric field. Okay, again, we're using the same apparatus, diffraction tube lah. Okay, so the difference here will be the procedure. 7-volt heater supply and 3 kilovolt power supply are connected, and also the 1000-volt power supply is also connected. But here the difference will be the metal plate reverse lah. So we reverse. So now the negative will be here. The short one is here lah. So the long one will be here. Okay, so we change the negative to up. The bottom will be positive lah. Okay, so now the beam will be moved down to the positive plate lah. Okay, so the cathode ray is diffracted downward, where is also the positive plate lah. So conclusion, the cathode ray is negatively charged. Okay, so we go to the question 5. So the first diagram shows the multi-class tube which is connected to EHT, extra high tension power supply, which is observed when S1 is open. So the S1 will be here, open. So that means here is off lah. When the power supply here is off, so that means the filament here is not provide any heat. So the thermionic emission will be not occur. So that means there will be no any light at the cathode here. Okay, so we can look at the A. There is no glow on the fluorescent screen. So the answer supposed to be A lah, right? Because there is no any light will be there is no any light will be on at the filament here. Okay, so the B, the cathode ray move with low velocity. C, cathode ray move with higher velocity. D, the shadow of the multi-class become clearer. Okay, so as mentioned, when S1 is open, so there will be no any power supply connected here. So the cathode will be not heated, so no electron will be produced. So will be A lah. There is no glow on the fluorescent screen here lah. Okay, so the 6 will be also the same question here. Okay, the difference here now is we read together the question first now. Okay, so diagram show the multi-class tube which is connected to EHT also, and there is a 2 switch here, S1 and S2. Okay, so now what can be observed when S2 is open? So now S2 open, so that means the first power supply here is connected. So that means there is a heating filament will be occur here, right? So the thermionic emission will be occur at the cathode. However, the anode here is not able to accelerate the electron because the EHT here is off. So that means the electron will be stay at the cathode. Okay, so will be have a light at the filament here lah. Okay, so that means the answer A, there is no glow on the fluorescent screen is wrong lah. There is a glow, okay, with the yellow color in front of the screen. So B, there is no green light appear on the fluorescent screen. So the answer supposed to be B lah, okay, because the electron beam will be strike the screen. Will be not strike the screen. Okay, because the anode not able to bring the electron to the front. Okay, so the answer should be B lah. So C, the cathode ray move with higher velocity. So will be not occur also lah, because the EHT is not on. Okay, so all the electron will stay at filament. So the shadow of the multi-cross deflect downward. So there is no any deflection because we don't have any magnetic field or we don't have any electrical field is bring towards the beam lah. Okay, so the answer here will be B lah. Okay, so the discussion here, when S1 is closed, 6 volt power supply is connected, filament heated, so the thermionic emission will be occur, so the filament will be light up, so a shadow will be formed. So electron will be stay at the cathode and not accelerate as EHT is not connected lah. So answer will be B. Okay, the next question number 7 will be, diagram show a shadow form on the screen of the multi-cross tube. Okay, so the shadow is deflected by magnet. So that means the shadow is deflected. Okay, we don't know what's the position unless you're using the Fleming left-hand rule, right? Okay, so the direction of deflection can be determined as mentioned. We are using the Fleming left-hand rule. Will be used. Answer will be A here. Okay, it's very clear. So answer is A. Yes. Okay. So, Gulan, hi. Okay. Thank you for your answer. Okay, in our chat room here. Okay. So I hope that you can continue to learn together with me. Okay, today. Okay. So for last question in our learning standard 2, question number 8. Okay. So the diagram show a multi-cross tube which is connected to EHT. Okay, here. Power supply and observed by pupil. Okay. So the shadow of the multi-cross will be moved when a magnet is brought near to the tube. So that means the shadow will be changed position. Okay, so we will using the Fleming left-hand rule to determine the position of shadow or the diffraction of the cathode ray here. Okay. Okay, so at which position the shadow will be moved? So the first, we need to know we're using the Fleming left-hand rule, your left hand. Okay. Okay, so as mentioned that the beam, electron beam moving forward, so that means the current will be opposite direction. So will be in. Okay, I put in here. I represented the current. Okay, is it A? Okay, so let us see, is it A? Okay, and then the second, here very clear that we have two bar with the different pole here. So as mentioned that the magnetic field will be from the north to the south. Okay, so your hand, the current will be, second finger will be in, right? Okay, and then our first finger will be go down. So you can see my thumb will be point towards myself, right? So will be at here. So the force will be here. So what's the answer here? So the answer should be D, right? Okay. So your hand will be almost like this. Okay, almost like this. Your first finger go down for this, and then your second finger will be go to the left, and you can see that your thumb will be point towards yourself. So will be D, answer. Okay, Gulan, hi. Okay, answer is D. I hope that you can understand. Okay, so answer is D. Okay, so we can take 5. Cikgu Yani.
Okey, terima kasih Cikgu P. Kita akan berehat dahulu dan saya akan tayangkan iklan. Okey, sekejap ya. Stay tune. Okey, kita persilakan semula Cikgu P. Silakan.
Okay, thank you, Cikgu Yani. Okay, so welcome back to our last learning standard 3 here. Okay, so the learning standard 3 will be, you must able to determine the velocity of an electron in cathode ray tube. So at this part is more on the calculation. Okay, so you can be preparing your calculator, okay, for this learning standard 3. Okay, so the velocity of the electron in cathode ray tube. Okay, so just now we already very clear that the electron beam will be accelerate, okay, from the cathode to anode, and then will be moving in the uniform velocity when they strike to the fluorescent screen here. Okay, so now we have to know the velocity of the electron moving in the cathode ray tube. Okay, and one more here is a vacuum. Here represented that there will be no any molecule, a molecule, okay, stop the motion of the electron. Okay, okay, so the first, okay, so you can see we providing the heat, okay, at the heating filament here. Okay, so there will be the electrical potential energy here at the first here. Okay, we using the symbol EP here. So electron are released from the cathode. Electron have electrical potential energy. So this is the first energy we supply, okay, to our electron. So the second, the energy will be converted, okay, to kinetic energy. We're using a symbol EK here. So electron move to the fluorescent screen. Electrical potential energy will be changed to kinetic energy. So this is due to we providing the second voltage here. So we know as the EHT, right? Just now I mentioned already, extra high tension. Okay, so causes the electron will be accelerate here. Okay, so that means they will be changed to kinetic energy already. Okay, and then the last here, you can see the beam will be strike. Okay, the screen, the fluorescent screen and appear. Okay, will be appear green color here, and we see a shadow, right? Just now we at learning standard 3, we know why this observation can be seen, right? Okay, so here you can see when electron hits the fluorescent screen, the kinetic energy will be converted to light energy. So this is conversion energy, which will be help you to more understand the determination for the velocity of electron in the cathode ray tube here. Okay, so very clear that just now I mentioned already. So the electron will be changed from the electrical potential energy to kinetic energy, and then last will be to the light energy here. Okay, so for the electrical potential energy, so the equation we're using here will be EV. And then the kinetic energy we're using 1/2 mv squared. This one you learned at the PT3 level already. Okay, so what is EV? What is M and V here? Okay, so this is the defined for the symbol here. So E will be charge of the one electron, and the value will be 1.6 times 10 power negative 16 C here. Okay, C will be column. Okay, the small letter m represented as the mass of the electron, where the value will be 9 times 10 power negative 31. Sometimes the question will given you the mass of the electron as 9.1 times 10 power negative 31. So we must follow the value given by the question. Okay, if I say the question given us the value at the front page of the formula with this value, you have to follow. Okay, you cannot say, oh, I memorized and I use this value. So there is sometimes minus difference between the value we learn with the value given by the question. So it will be 9 or 9.1. Okay. And the capital V here represented as the potential difference between anode and cathode here. So it will be here with this. Okay. So this is a potential difference between anode and cathode. So it will be the EHT value here. Okay, and then the small letter V will be the velocity of the electrons, where we need to determine, okay, in this learning center 3 here. Okay, so from the principal conservation of energy for each electron, the electrical potential energy EP here will be equal to the kinetic energy. Okay, because the principal conservation of energy state that so the energy can be created or destroyed, but can be changed from one form to another. Okay, so here will be changed from the electrical potential energy to the kinetic energy. So there will be no any loss here. Okay, so that means the EP, the electrical potential energy, will be equal to kinetic energy here. Okay, so the EV will be equal to 1/2 mv squared. Okay, so we rearrange the formula, we get our V will be square root 2 EV over M here. Okay, so we need to use this formula for the calculation. So you must remember this formula. Okay. Okay, so we go to our checkpoint question. Okay, number 9. Okay, so there will be the question regarding learning standard 3. Okay. Okay, so here I accidentally give the answer here already. Okay, so never mind. So you can see how I solve the question here. Okay, so diagram show an electron. So an electron is here. From a cathode is being accelerated towards an anode. So the anode will be front. Okay. So the potential difference across the two metal plate will be 750 volts. So that means this value is actually the EHT value. Okay, because of the potential difference between the anode and cathode causes the electron move towards the anode. Okay, the theory just now I explained already. Okay, so the question asks you to calculate the speed of the electron. So it will be V, small letter V. And the question given us the mass 9.1 times 10 power negative 31, and the charge of the electron will be 1.6. Okay, so as Bill mentioned just now, so here will be the V, capital V, okay, given as 750 volt. Okay, and we using this formula, we substitute all the value to E will be this value, and then the capital V will be 750 given by the question, which is the value of EHT. Okay, and the small letter m is 9.1 times 10 power negative 31. So you use your calculator, you will get the answer is 1.62 times 10 power 7. Okay, is for the paper 2, you have to give the correct unit with at least 2 decimal places here. Okay, for the last 2. Okay, question 10 and question 11 will be the partial question in section A. Okay, so diagram show a simple cathode ray tube cathode emits electron when switch P is closed. So switch P closed, so that means the heat will be provided for the filament. So the electron will be emitted at the surface of the cathode lah. Okay. Okay, so name the process that enable the emission of electron at the cathode. Okay, so students, you may also continue, okay, to show your answer at chat room lah. Okay, so here is very clear. Okay, so the process is, so what is the process here? So will be the Thermionic emission. Okay, very simple question. Okay, and then for the B, state one reason why the extra high voltage is used. So extra high voltage, that means is EHT lah. So the purpose will be create the difference between cathode and anode so that the electron will be attracted in front or accelerate in front, right? So here 1 mark will be 1 point. So answer here, to accelerate the electrons to a high velocity to the anode. Okay, so you might mention accelerate electron with high velocity to the anode here. Okay, so the next will be when electron flow in the cathode ray tube, the current produced in 5 seconds is 0.01 ampere. Calculate the total charge of the electron. Okay, so the total charge will be Q. Then 5 seconds will be time second. So here 0.01 will be current. So this relationship between Q, T and I is not discussed in this subtopic, but we already know in chapter 3, year 3 actually. So the formula used here, okay, as mentioned just now, I given 0.01 ampere, T will be 5 seconds. The question asks us to calculate the value of Q here. So you have to using the formula Q equal to IT. Okay, so that means this question able to relate to the chapter we learned at previous lah. Okay, so we using calculator, we get here will be 0.05 column lah. Okay, it's quite straightforward question. Just the formula we not discuss in this subtopic, but in previous chapter already. Okay. Okay, so the D diagram 10.2 will be this lah. Shows an incomplete path of a cathode ray in electric field. Okay, so as per mentioned just now, we will see the diffraction of the cathode ray in the metal plate here. So, okay, so you have to complete the path of the cathode ray. So here you can see the positive will be at the top plate, top metal plate, and then the negative will be here. Okay, so we know that the cathode ray will be negative, so that means will be move up, right? Okay, move towards the positive plate lah. So here will be 1 mark lah. Okay, so this is the positive, bottom is negative. Okay, so the you can draw like this also same lah. Okay, so we just need to draw one line lah. Okay. Okay, so the next, give one reason for your answer in D1. So why? So just now I mentioned already lah, because the cathode ray is negative charge, right? Okay, so the cathode ray are negatively charged particles will be moved to the positive plate. So I think this question is also not very hard, I think. Okay, so we go to our last question. Okay, so this question also the paper 2, section A question in 2016. Okay, so diagram 11.1 shows a closed section of the multi-close. So the multi-close is here. Tube, this one, this apparatus, which is used to study the characteristic of the cathode ray. The cathode ray is produced when electron emitted from a heated cathode. So the heated cathode will be here. So again, the question asks you, name the process of emitting electron from the heated cathode. So again, the question asks you to name the process. So just now, I already tell you, okay, so the process will be thermionic emission. Okay, so question 10 and question 11 both is also the partial question. Just the way they ask is different, but actually they test the same definition for the thermionic emission. Okay, then the next here. Okay, so the diagram 11.2, so be here lah. This will be the 11.2. Show a shadow and the green light region seen on the screen. Okay, so here will be the shadow, and here will be the green light. Okay, so give a reason why the shadow is formed on the screen. Okay, so why we have the shadow? Because the light travel in straight line. Okay, so cannot pass through an opaque object, so be blocked by a multi-gloss. Okay, so this is a reason. Okay, so you can see light from the heated filament travels straight line and blocked by the multi-gloss, which is an opaque object. So the reason here, the light from the heated filament is blocked by multi-gloss, which is the opaque object. Okay. Okay, then the next question, the green light region is formed on the screen. So why we have the green light region here? So the electron will be strike the foreign set screen. Okay, converted the kinetic energy to the light energy. Okay, as we mentioned just now, right? Okay, so the electron strike the fluorescent screen will be the answer here. Okay. Okay, so the next will be calculation. Okay, so electrical potential energy 4.8 times 10 power negative 16 joule. Okay, gained by electron is converted to kinetic energy of the electron in the multi-cross tube. So calculate the velocity. Okay, so here the electrical potential energy given by question will be 4.8 times 10 power negative 16 joule, and the question asks us to find the velocity for the electron will be small letter v. Okay, and according to our explanation just now, the electrical potential energy will be equal to kinetic energy. So we get this lah. Okay, and then we get V equal to 2 EP over M. Or you can just actually using the same equation, 2 EV over M, right? So the EV will be the electrical potential energy actually. Okay, so you straight substitute EP for EV here. Okay, so 2 times EP, 4.8 times 10 power negative 16 joule here, divide by the M. So the M, the question given, okay, the question given actually 9.1 actually. Okay, it's 9.1 because I substitute 9.1 already. If I say you substitute 9.0, will be a bit different, okay? It'll be a bit different. Okay, so with the value M, which is 9.1 times 10 power negative 31, so you'll get 3.27 times 10 power 7 meter per second. So your answer must be at least 2 decimal places with the correct unit here. So the first mark will be given for your substitution. Second mark will be for answer with sufficient decimal places, which is 2 at least, and the correct unit. Okay. Okay, then the D. Okay, so using 11.3, diagram 11.3. Okay, so here showing there is a 2 magnet with the opposite pole are placed at the side of the tube, causing the shadow being deflected. Just now we know already. We must using Fleming left-hand rule. Okay. Okay. So you have to draw. Okay, draw the diffraction position. Okay, diagram 11.4 shows front here. Show the front view of the screen seen by an observer here. So the observer will be here. So in the diagram 11.4 here, draw an arrow to show the direction of the diffracted shadow here. Okay, so first the current flow. Okay, So here actually the answer lah. The current flow will be into the tube, right? So be here. Okay, so we indicate by your second finger. So be to the left lah. Okay, and then the magnet here, north will be here. Then S will be here, so it will be from here to here. So your first finger must be point in your screen lah. Okay, so then you will see your force, your thumb will be showing downward. So important lah. Okay, okay, so I just now explained to you already lah. Okay, so the current will be flow in, which is opposite direction to the electron beam. Okay, second, you can see the blue color line arrow here showing the direction of the magnetic field from north to south. Will be here. Okay, so you see current opposite direction to left, and then here will be north to south. So your thumb will be downward. Okay, will be like this lah. Okay, so first finger, current will be to your left. To your left, if you see you see the laptop, okay, so that means it will be opposite lah. To your left, your left, not my left. Okay, then your first finger will be to the screen, in, not to south. You can see the question will be more clear. Or not look at me lah, look at the question. Okay, and then your thumb will be go down. Okay, so that means the answer here will be the arrow moving down. Okay, will be showing as F lah. Okay, if you show an arrow, actually is already sufficient. Okay. Okay, then the last step, the physics rule used to determine the direction of the shadow. So this one very easy lah, will be Fleming left-hand rule lah. Okay, remember your spelling must be correct. If I say you write as 2M, they will be wrong. Okay, so must make sure that the Fleming, the spelling is correct. Okay. Okay, so that's all for my sharing for subtopic 5.1. Okay, I hope that all of you able to understand. Okay, thank you.
Okay. Alright, terima kasih kepada Cikgu P atas perkongsian yang sangat padat dengan info yang menarik tadi. Sekejap ya, saya nak pastekan link sijil bagi siapa-siapa yang ada. Boleh tuntut sijil di link ini ya. Okey, tahniah diucapkan kepada semua yang setia bersama kelas pada kali ini dari awal hingga ke saat ini. Sekarang kita tunggu link ya. Link saya sudah letakkan tadi. Okey, sila ambil perhatian. Link tersebut akan tamat dalam tempoh setengah jam selepas live ini ya. Okey, pastikan anda menggunakan email didik semasa mengisi borang ini. Kita ada MOE juga. Kita ada Jawi, Guru, My Guru. Kemudian kelas seterusnya untuk subjek fizik adalah pada hari dan waktu yang sama pada minggu hadapan. Tolong sampaikan kepada rakan-rakan kamu semua ya. Sila layari www.academyyoutuber.com untuk dapatkan info terkini dan jadual kelas tuition percuma ini. Percuma sahaja ya. Jom kongsikan portal AYU ini kepada rakan-rakan dan guru-guru seluruh Malaysia. Juga diingatkan, semua kelas online percuma ini boleh ditonton semula melalui link yang disediakan di portal AYU. Kita tiada kod hari ini sebab ada masalah teknikal. Okay, kemudian semoga kita mendapat manfaat daripada kelas-kelas yang telah dijalankan. Ingat hashtag bermula percuma, selamanya percuma insya-Allah. Kita ada penggolongan ke Cikgu P?
Okay, so terima kasih lah, especially kepada Cikgu Yani lah bersama saya pada petang ini. Okay, dan juga terima kasih kepada para pelajar yang bersama saya pada petang ini. Okay, so harap boleh teruskan belajar bersama kami, okay, sokong kami supaya kita buat lebih semangat, okay, dan beri contribution yang seterusnya. Okay, thank you cikgu.
Okey, terima kasih. Yang baik datangnya dari Allah dan sebarang kekurangan datang daripada kelemahan kami sendiri. Bunga dedam di atas para anak dusun pasang penita. Andai tersilap tutur bicara, jari disusun, maaf dipinta. Sekian, terima kasih. Jumpa lagi di minggu hadapan. Assalamualaikum. Bye-bye.
Wow, banyaknya hadiah menarik menanti anda.
Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma.
Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.